Hello again, it's Mr. Savannarath here. This is your part 2 of 4.3 for Precalculus period 4. Okay, so this is about the inverse function, inverse trig functions. A quick way to remember them is this, okay? Just to give you a quick review here. If you take your sine of any angle, which we'll call theta here, anything has 1 underneath it. Just remember that. So if I take 1 sine over 1, if I flip this upside down, right, that should be 1 over sine. So 1 over sine, I know my handwriting is bad over there, is the same as this guy, which we call it cosecant. All right, so cosecant. In the second line there, this line here, if you take your cosine over 1 and you flip that upside down, you'll get 1 over cosine, and that is what we call the secant. Now, tangent and cotangent is the same thing. So if you take your tangent and flip it upside down, you make it a cotangent. Now, what's the business on this side here? Well, cosecant, is 1 over sine. Now, in the unit circle itself, let me go back here. This is the y-coordinate. Y-coordinate is the opposite from the angle. We call it the sine. So the sine of the function is the same thing as your y-coordinate. Okay, in fact, it's the radius times that. We'll talk more about that one. So instead of having cosecant being 1 over sine, you can call it 1 over the y. And then for secant, it's 1 over cosine. Cosine is, again, on the unit circle, is the distance on the x-axis. So however long that distance is. So just put that down there. So you can use that numbers to figure out things, okay, instead of just random symbols. Cotangent is the y over the x, while tangent is the x divided by y. It's the opposite over adjacent, okay? You're welcome to review this part of the lesson. I don't want to spend too much time here. Just something you have to remember. Oh, one more thing. One way that I keep myself from getting confused between the secant and cosecant, because cosecant sounds like a cosine. Cosecant sounds like a cosine, but actually it's not. Sounds like a cofunction of a cosine. So this is the way I keep track of things. C and S are always inverses of each other. Okay, for example, cosine, the inverse of a cosine is a secant. C and S. If you pick up a sine, if they say what is the inverse of a sine, S and C are inverses of each other. So that would be cosecant. Okay, these are the inverses. These are the original functions. Most people are not confused with cotangent and a tangent. So just get these two straightened out, then you'll be okay. All right. Next part. We're going to look at the unit circle for a little bit, because the unit circle here is going to help you with any circles or any coordinate points on a circle with different radii. Okay, oh, I should say radiuses. That's a joke. Okay, here's a unit circle with this radius being 1. There is your radius, right? This radius is 1. Now I just made an angle here of 45 degrees because it's easiest for me to draw a 45 degree because it goes right through the corner of a square. So the coordinate point, as you can see on this side, is 0.7 and 0.7. So this point right here is 0.7, 0.7. Let me see, I'm gonna go into my writing tool. So I got 0.7 here and 0.7 there, right? If you look at it, that's about 0.7. It's because 0.5 is here. 0.7 on the x and 0.7 on the y, all right? So now if you take your square root of 2 divide by 2, that is exactly 0.7. Let me grab my calculator here. Okay, so here's my calculator. Don't know if you can see it. I'm trying to get that in there. So square root of 2 divide by, gotta get on with this calculator here. All right, divide by 2. There you go. There's 0.7. It's that, in fact, they round up to 0.71. Okay, so I'm gonna leave that a little bit. So now what happened? Well, the number has 1 in front because the unit circle is 1 on the radius. So if you take 1 times 0.7, you got 0.7. Now, if your radius is longer than 1 or shorter than 1, all that is, it's just going to be, let's say the radius is 2, we'll take a 2 times that, right? 2 times 0.7, which is 1.3, 1.4-ish. Should be 1.4, right? Anyhow, so when you multiply like this without the decimal point, you can simplify your numbers down there, your 2 and the 2. So that's the same thing as square root of 2. I'm gonna get square root of 2 here. There's your square root of 2, 1.7. Okay, prove that. How do you prove this? Let me see. I'm gonna make this length here a 2 now. So there's my 2. Hopefully that's on a 2, but if I'm close, I'm good. All right, that's 2. So now if you look at the radius that I have here, point B is sitting on 2. This right here, we said it's going to be 1.4-ish. So there's your 1.4. Okay, so now what is going on here? Well, that is, I just talked about that. The radius here is 2. So you take that 2 times 0.7. Now, if this radius is 3, this would be 3 times your root 2 over 2. Now, in math, this is more precise answer than your decimal point. So I would prefer that writing over your whatever the 0.7 times 3 is. It's like 2.1-ish. Okay? All right. So let's move on to the next page. I know this would be a little bit longer than I thought for the video for part 2. Anyway, so let me see. I'm going to move on. Come on. I can't really do anything here. On to the next page. Oh, that's backward. Okay. On. Yeah. Okay, there we go. So you might want to take a snapshot on this page, okay? Go here. So take a snapshot on that page. So the formula for the coordinate point, if you have the circle with different size radius, so your radius can be any number, even some weird looking numbers like 2 root 3, 4 pi, -7, 3 root 7, whatever that is, just ignore that. All you're doing is you take these radius number and pop it in there, and the cosine is the x value from unit circle that you know. The sine is the values from your unit circle. All you do is you multiply those in there. And these only work for unit circles only, okay? All right? For circles with the angles from the unit circles, I'm sorry about that. It's pi over 3, pi over 6, pi over 4, and those type of angles, because we don't know other values, but it will help you estimate other parts. All right, so here we go. What would be this coordinate point here? Just a quick example. So right now I got the angle being pi over 4. So I'm going to say where is, from my unit circle, what is the sine and a cosine on pi over 4? What's the value? Okay, so quickly remember that. This would be 2 root 2 on the sine, or on the cosine part. On the sine is the same thing, it's 2 root 2. Then we just put a 12 in the front. Now when the 12 comes in like that, they can simplify with your 2. So this coordinate point would be 6 root 2, because 12 divided by 2, and 6 root 2, like that. Okay, Now, if the angle is at different location, for example, if your angle is over here, which is your 5 pi over 6, this coordinate point is going to be different. This coordinate point would be negative root 3 over 2, comma 1/2, right? And then what you're doing is you put your 12 right here. I know my writing on the board is not as good. So now 12 divided by 2 should be 6, but that's going to pick up a negative sign, so that coordinate point would be negative 6 root 2, or root 3, comma 6. That's all. Okay? My handwriting is really bad. The board just kind of messed up. Okay, I'll sign out for now. I'll come back for a third part.